What if I told you that your favorite online game could be used as a doorway for hackers to take over your computer? Sounds scary, right? Today, I'm exploring an important topic that I'm really passionate about that needs more attention in the gaming world, and how I found a vulnerability in a specific popular video game that could let someone on the same Wi Fi network run harmful code on your device. Please note, this isn't about fear mongering, it's about understanding how this class of vulnerability works and why it's so important for game developers to design hotfixes and patch updates in a secure and safe way. Before I dive in, I want to be very clear. I'm not sharing any technical details or steps to exploit this issue. It's purely educational and aims to promote awareness and safety of both players and of game developers. And I'm not endorsed by NetEase Games or Marvel Entertainment. So here's how this started. I was casually playing Marvel Rivals, which currently has over 200,000 concurrent players on Steam right now. So a lot of people are susceptible to this. Um, I noticed something odd about how the game updates the cosmetics store, and it does so without a client patch. There's no client update. So I dug a little deeper and realized there's a flaw in how this patch system works. Originally, it was designed so that the game developers could run code to update parts of the game on your device, but there's a flaw that could allow someone to use this to execute code on your device. This is what the security industry calls remote code execution, or RCE. So just to give you a little background on RC, if you're not familiar, imagine you're at a cafe connected to public Wi-Fi, you're playing an online game, having fun. Unknown to you, someone else on the network is looking on looking at these network packets going through the air. Um, and if an application's network code is not secure and can execute code that comes over the network, that rogue person could send malicious commands to your app and infect your device without you knowing at all. That's RCE in a nutshell. To show how serious this can be, I created a test environment. This setup includes two devices I own, my gaming desktop and my travel laptop, that are both connected to the same network. I'm recording this video and running the exploit from my desktop, and I'm remoting into my laptop to have it included in the video. It's this window that says remote desktop connection. Now we can get to the demo, which is the most exciting part. So I'm going to go ahead and launch Marvel Rivals from my gaming laptop. Oh, and this is also hilarious. The game itself requires admin privileges for the sake of their anti-cheat. So the game has full privileges, which is great. So I'm going to go ahead and approve that and sign away my computer to the game. And then it takes a second to launch. So give me a second, bear with me. All right, so while this is launching, I'm on my desktop. I'm going to start my tool, my exploit tool, and all it's going to do is be sniffing for packets and waiting to inject a Python script. This Python script I have it posted on the top right. It's just a simple command that shows who you are, if you're a user, if you're an admin, um, and shows that, hey, you do have admin privileges. So it's compiling shaders. So we gotta give it a second. Those shaders are compiling as fast as they can on my little laptop. So this is still just passively sniffing packets, waiting for the game to connect to the server. Bear with me. Okay, so at this point, when I click start, the game is going to start communicating to the game server, and I'm hopefully going to be able to see it on my system. So I was able to sniff these decryption keys and encryption keys to inject this Python script, which will pop a window up here in a second. Boom, there it is. That's the RCE. At this point, my laptop is owned. It's sending all my passwords to some malicious user or mining bitcoins. So yeah, that's the demo. It's kind of crazy that it's that easy, but that's what it is. So the scope of this bug is limited to an attacker being able to see the network packets and send packets on your network. What this means is they have to be on your local area network or Wi-Fi, for instance, your house, a coffee shop, or a college campus. Um, it also extends to internet service providers such as Comcast employees that have access to looking at packets going over their network, and cloud vendors where the traffic goes through also. So AWS or Azure employees. Thankfully, we can trust employees from these companies, right? Um, so the biggest security gap in NetEase's implementation is that their network protocol generates this key material uh, through pure symmetric encryption without using a real public key infrastructure. What this means is that the game has no way to verify it is connected to the real game server. The game also runs with admin privileges for the sake of their anti-cheat system to work, which should be limited, but it's not. So because of those two reasons, a rogue user is able to inject Python effectively into the target machine. A lot of games do have some sort of remote code execution for their patch update system, but they usually have they don't have that gap where number one, they need to create a secure channel with the game server that verifies they're actually talking to the game server, and number two, don't run with admin privileges. When I discovered this issue, I immediately reached out to NetEase. However, since they don't have an official bug bounty program, I attempted to contact them through a bunch of different channels, through customer support, random LinkedIn people that work in IT at NetEase, and just common security email addresses. Unfortunately, I received no response regarding a timeline for a fix. Um, and it really highlights a broader issue in the gaming industry that most gaming companies lack proper security disclosure processes, and a lot of them don't even care. But at the end of the day, security in gaming isn't just about stopping cheaters, it's about protecting players and the player base. If more companies took security seriously, the gaming space would be much safer for everyone. So that's it for today. Hope you found this video informative. And if you enjoyed this or want to see more deep dives into game security, let me know in the comments. Uh, so yeah, thanks.